One of the keys in producing high-quality, crystal-clear ice is using purified water. In order to produce the quality of water needed, a multi-phase solution should be incorporated. The water is then pumped into a storage tank so that an ample supply of water is always available to the ice makers. System. The water is passed through a chiller manufactured by Turbo. The chiller is capable of bringing the temperature of the water to 34 degrees before it enters the ice makers. The ice makers shown are Vogt P34 extended barrel tube ice machines. Each ice maker can produce 75 tons of ice per day. Once a machine's harvest, ice is discharged into the collection screw. The collection screw incorporates a surge bin as well as a reversing screw to handle the large amount of ice discharged by each ice machine. The collection screw moves the ice to a Matheson dewatering belt conveyor. The ice drops to a secondary dewatering belt conveyor before entering the shaker bed. The shaker bed separates the fines and snow from the quality baggable ice. Fines and snow are diverted into a melt tank for melting and disposal. This cool water is pumped back into the evaporative condensers, thus saving precious water resources. The ice then continues on to the drying system. Ice is still wet on its outer surface when it is harvested. If left in this condition, the wet ice cubes would freeze together, creating an unmanageable, solid piece of ice. Removing all of the moisture from the ice before it is packaged and stored eliminates this problem. Screw conveyors are used throughout the ice plant, conveying ice to the rake and other storage systems. This bin rake system built by North Star offers a great deal of storage. Each bin shown here can store and handle 200 tons of raw product. This method of storing ice is very efficient and cost-effective. The bin rake provides a sanitary environment for ice storage. All materials such as stainless steel and UHMW plastic used in this system are of food-grade quality. The conveyor moves the ice to the snow reel, manufactured by Matheson equipment. In this process, the ice enters on one end and then spins as it travels through the snow reel. The outer wall of the snow reel is actually a wire screen, which allows the snow and fines to be removed from the ice before it is sent to a distribution hopper and then on to the packaging system. Unused snow is diverted to several tanks where it is melted. Several systems can be used to melt the snow. Screw conveyors are used to transport the ice to an ice distribution hopper, which has multiple screw conveyors mounted underneath to feed the bagging lines. Modern incorporates the latest packaging machines manufactured by Hamer, Matheson, and JMC. In this facility, Hamer models 535, 1550, and 540 packaging machines are used. This equipment utilizes pre-printed bag roll stock, which is converted into a bag by the machine. As you can see, the bag gusset is actually formed by a special mechanism mounted just after the roll stock mount. The bag is created through a heat sealing process. The size of the roll stock can be changed when other weight packages need to be filled. The roll stock is pulled down the line and filled by the volumetric filling system, then sent on to be closed by the included heat sealing unit. Balers, such as those manufactured by JMC and Matheson, are used to nest multiple smaller bags into one master bale for ease of transport. A JMC Fusair 4 heat sealer is being utilized to seal the baled bags. Once the ice is baled, it is placed on pallets and stored, awaiting shipment. The cold storage room shown is built using prefabricated locking panels. These panels are assembled to construct a variety of sized and shaped rooms. Multiple rooms were constructed within. The entire plant is controlled by a central control panel with a micro relay system. Sensors are located throughout the plant, detecting everything from high ice, low ice, non-functional